So good morning children. So last class we have discussed up to last class we have discussed up to Pascal's law. So what is mean by Pascal's law? Okay, so if you are taking one closed vessel, we have to fill with incompressible liquid. Okay, incompressible liquid. Okay, what is mean by compressible and what is mean by incompressible? So compressible means what? We may give the pressure or force. Okay, so it may change the air shape. Okay, suppose we may withdraw the force or pressure, again it will retain their original shape. Okay, that is called compressible. Okay, so incompressible means what is the meaning? So we may give force or pressure also, it will not change the air shape. So that is called incompressible. Okay, so we have to take the incompressible liquid. Okay, in a closed vessel, we may apply the external pressure. We may apply the external pressure. So what will happen? Okay, the external pressure applied to incompressible liquid is transmitted uniformly throughout the liquid. Okay, so this law is called Pascal's law. Okay, so up to this last class we have discussed. Okay, so today we are going to start the new topic based on the Pascal's law. So many instruments are working. So based on what law? Pascal's law. Okay, so in that, okay, one is given, okay, that is called a hydraulic device. ULIC, hydraulic device or hydraulic press. Okay, have you seen the JCP? Okay, so works on the principle, what principle ma? So Pascal's law principle is usually in where? JCP, okay, earth excavators. Okay, so these type of machineries works under the which principle? Pascal's law principle. So here we have to take two different what ma? Okay, two different cylinders contain different cross-sectional area. Contain what ma? Different cross-sectional area. Okay, so here this one A1, A2. Okay, here pressure, here also pressure. Next we have to close with the help of piston. Okay, here force F1, here force F2. Here we have to keep where ma? One of the object on where ma? On the surface of the piston, second one. Okay, so now, okay, we may apply the what ma? Force or pressure. The force F1 is applied on the piston of a small cross-sectional area A. Small cross-sectional area A. Okay, this is small cross-sectional area A. This one biggest one. Okay, so we have to apply the force. We have to apply the force where? The small pistons. Okay, so what will happen? Okay, the pressure P produced by a small piston is transmitted equally. So we may apply the pressure. Okay, so with the help of pressure, okay, with the help of force, okay, so pressure has created, okay, get transmitted equally to the large pistons, and the force F2 acts on A is greater than the F1. Okay, so here F2 is greater than F1. Okay, so based on the what formula? So pressure formula, pressure is equal to, okay, so F1 divided by A1. The same way, pressure is equal to F2 divided by A2. This is equation 1. This is equation 2. Okay, so P is equal to F1 divided by A1. P is equal to F2 divided by A2. So we have to compare the equation 1 and 2. We have to compare the equation 1 and 2. Okay, so F1 is equal to A1, F2 is equal to A2. So we need F2 alone, we need. Okay, so F1 divided by A1 into A2. So therefore F2 is equal to F1 divided by, okay, so A2 you have to bring here. So A2 divided by A1 into F1 into F1. Okay, this is the final formula. Okay, so if the ratio of A2 divided by A1 is greater than 1, okay, if the ratio of A2 divided by A1 is greater than 1, the force F2 acts on the large piston is greater than the force F1 acting on the small piston. Okay, so this value, which value? A2 divided by A1 value is greater than 1. So what is the meaning? The force acting on this area is greater than the force acting area of this one. Okay, so F2 is greater than F1. Okay, so these type of systems working on this way, they are known as force multipliers. Okay, they are known as force multipliers. Okay, so that's all. This one, which one? Hydraulic press. So next one, density. Next one, density. So what is mean by density? So what is mean by density? So what is the formula? Density is equal to mass divided by volume. Mass divided by volume. So if you are taking the two different object, okay, volume is same. Volume is same. Two different object we are taking. Okay. Two different objects we are taking. Okay. So volume equal 250 ml, capacity here 250 ml. Okay. So we have to fill with the liquids. Okay. One is water. Another one is what, ma'am? Kerosene. Another one is kerosene. Another one is kerosene. Okay, so what is the volume? 250 ml. Here also 250 ml. So what is the weight of water? Okay, so 250 plus 80 is equal to 330. Okay, so empty weight is equal to 80. Okay, here empty weight. Okay, here empty weight what, ma? Okay, so 220 plus what, 80. Okay, so here empty weight 80. Okay, so mass of the liquid 250 is equal to 350. Okay, so here 280. Here 280. So mass is equal to what? 200. Okay, here mass is equal to what? 250. Okay, so we have to find out the density of this one. So density is equal to what? Mass divided by volume. 250 divided by 250. So automatically what is the answer? 1 gram per 1 centimeter cube. Okay, here 200 divided by 250 is equal to 0.8 gram per centimeter cube. Okay, 0.8, here 1 gram per centimeter cube, by here mass equal to 250, here mass equal to 200. Okay, so unit gram also we can use. Okay, or kilogram also we can use. Okay, the same way, suppose if you are using ml, gram. Okay, suppose if you are using liter, here we cannot use gram, we can use what, ma? Kilogram. Okay, just we have to compare these two substances. Which one has more density? Water. Which one has less density? Kerosene. So if you are taking the petrol also, some other liquid also. So based on this, we have to define the definition for density. So density is equal to, density is defined as amount of, okay, mass present given by the volume of the substance. Okay, that is the definition for what? Density. So how to define the density? So density is defined as, okay, substance of mass present in where? Okay, present in per unit volume of the given substance. Per unit volume of the given substance. So formula is equal to, okay, gram per, okay, volume. Okay, gram if you are using means what, ma? Centimeter cube. Okay, suppose if you are using kilogram, Okay, so meter cube. Okay, so what is the symbol of density? Rho. Okay, what is the symbol of density ma? Rho. Okay, this is the small information about what? Density. Okay, next one, relative density. So what is mean by relative density? Okay, why we want to use the term relative density? So relative density means what ma? We have to compare the two substances to find their masses. So with the help of relative density we can find out their masses. Okay, here we are using relative density. Okay, so with the help of what ma? Water we are comparing. Okay, so relative density is equal to what ma? Density of the substance, density of the substance divided by density of water at 4 degrees Celsius. So why we are taking the water at 4 degrees Celsius? Okay, water at 4 degrees Celsius, the density of water is equal to 1 gram per centimeter cube. 1 gram per centimeter cube. So that only we are comparing with the water. So relative density is equal to the ratio between the density of the substance divided by density of the water at 4 degrees Celsius. Okay, so instead of density we may apply mass divided by volume. Mass divided by volume. So mass of the substance divided by volume of the substance. The same way here, mass divided by volume. Mass of water at 4 degrees Celsius divided by volume of water at 4 degrees Celsius. So both the volumes get cancelled. So what is the final formula? What is the formula? So mass of the certain volume of the substance. Okay, so mass of the certain volume of the substance, mass of the certain volume of the substance, okay, divided by mass of equal volume of water at 4 degree Celsius. At water 4 degree Celsius. Okay, so this is the equation for what ma? Relative density. So relative density is equal to mass of certain volume of the substance divided by mass of equal volume of water at 4 degree Celsius. Okay, so up to today class is enough. Okay, so the remaining heading here we will see in the next class. Okay, so thank you children. So today what is the homework for you? Okay, so define Pascal's law. Okay, so what is the homework for you? Homework ma, one is Pascal's law, second one, okay, so explain the working of hydraulic press, third one, density, okay, give its unit, fourth one, relative density, okay. Total how many questions are given today? One is define Pascal's law, second one explain and working of hydraulic press, third one define density, give its unit, fourth one define relative density with the equations. Okay, that's all. today class is enough. So remaining part we will see in the next class. Okay, so thank you children, thank you.